Hi, my name is Paola and this is my Programming Embedded System project at Florida International University. Today I will be presenting the Smart Home Appliance Control System, a fully functional embedded control built on an Elegoo UNO R3, which uses the ATmega32AP microcontroller. This project demonstrates the core concepts covered throughout the course: ADC, PWM, GPIO, UART, timers, and state machine, all implemented in C++ using the Arduino IDE. The system automatically controls a DC fan motor based on a real-time temperature and humidity data, with 3 operating modes: auto, manual, and sleep, additional a safety alarm condition when temperature exceeds or defined threshold. So, here is the complete hardware setup on an A30-point breadboard. The main microcontroller is the Elegoo UNO R3, running the ATmega32AP, the same fundamental architecture as the PIC 18F4520 we studied in class. So, our prototype now is turned off. There is no voltage flowing. So, we are going to talk about every part that we have here. So, our first model is going to be this one, the DHT11. So we're going to take out this thing to see it more here. So inside this blue thing, we have 2 sensors, the temperature and the humidity sensor. So we have 3 pins. This one is for data reading, the middle one is for voltage, and this one is for ground. So in our circuit, in this part, we don't have a resistor. Why? Because in our model, we already have a resistor, so we don't have to add it. So we're going to put it back into the prototype, and we have here ground, voltage, and data. The data is going to be in the digital pin 13. The next model is going to be the photoresistor. So this one is a passive semiconductor sensor whose resistance decreases as light intensity increases. So this model, this sensor, is used for light detection. So as there is high resistance, that means that the room is dark, and if we have a low resistance, that means that the room is bright, there is light. Our next model is going to be our fan motor, this one. So 2 main things is going to be our transistor and our diode. So here we have a PN2 transistor that it's like NPN BGT part. So we have one pin that is the gate, the controller, and the meter. And here we have a diode. So the main function of this diode is convert alternating AC to DC. So we want our motor to be constant, not changing between 0 and 1. We want it to be constant. So our next model is going to be our state machine. So we are going to use the LEDs. So we have 3 LEDs. We have green, blue, and red. So our prototype at first, in the beginning, at the starting point, by default, is going to run in auto mode. So the green light is going to turn on. These 2 buttons are used to change between every mode and implement the manual function. So this first button, that's in the pin number 2, is going to change the modes. So we have 3 modes. We have auto, manual, and sleep. So we are going to start in auto. If we click here, we're going to manual. The blue light is going to turn on, and we're going to use the second button that is in pin number 3 in the PWM. So on the PWM, that means that we can change the range of the voltage. Instead of having 0 or 5 volts, we're going to have 0, 3 volts, 1 volt. We can change it. We have a range because we are in the PWM, as the fan motor is the same thing. So this one, we are going to be able in manual mode to change the speed of our fan. If we wanted to have it off, if we wanted to have it low, if we wanted to have it high, full speed, we can change it in the second button. And we click again another time, 3 times, you're going to sleep mode. It's going to be the same blue LED, but it's going to be like not too bright, because it's going to be in sleep mode, or fan is going to be off, or prototype is going to be like off. And then we can go back to auto, clicking the same first button. And what happened with the red LED? Well, the red LED is used for the alarm mode, that is our interrupt function. So if our temperature is higher than 35 Celsius, we are going to make the interrupt happen. So our prototype is going to be off, or fan, everything, or modes are going to be off because we are in alarm mode. So we have here an active buzzer, so it's going to make a sound, and this LED is going to be on. Here in our LCD display, we're going to have alarm mode. So how we can change between modes? I want to go to manual, I want to go to auto, I want to go to sleep first. We have to tackle the high priority of this alarm mode. So we need to decrease the temperature of the room. Why? Because the alarm mode, that interrupt moment, is triggered by high temperature. We want to protect our components from high temperature. So that's why we have this interrupt moment with high priority. And we have this part that is to change the brightness of our LCD display. If we want it to be dark, if we want to be in between, we change it with this thing. In our LCD display, we are going to have our temperature in Celsius, our humidity, and the mode that we are. And this LCD display, we have 16 pins. 6 of them are data. We use 4 of them. And we also have an enable and a reading and writing pin. So in the manual mode, in the green LED, in the default mode, our fan is going to be controlled by the temperature. So if the temperature reach, for example, 20 degrees Celsius, we're going to start our fan in low mode. If we have a higher temperature, like, I don't know, 25, we are going to increase a little bit the speed of our fan. If we have more, it's going to be full speed. And if we reach that maximum temperature that is allowed, it's going to turn off and activate the alarm mode. To change the fan speed, we need to go to manual if the user wants to change it. So now we're going to start the demo and see how it works. So we're going to connect it by USB. We're going to put the 5 volts there through the microcontroller, and works with the resistors and everything. So we also can use a power supply or a battery or anything. So we're turn on. So we have this thing, and we're going to auto mode. So our fan is going in low because we are in 22 degrees Celsius. So we have a appropriate room temperature. If we want to change our fan speed, we must go to manual. So we are going to click on this button. It takes time because the buttons have like a loose contact, because it's not like soldered there. So we have to press it and wait till the light turns, the blue light turns on. So now we are in manual mode. So once we are in manual mode, we are able to change the speed of our fan. So we're going to click this button, and it's going from low to the next speed. It increased the speed. Now we're going to click again, increase again, and now we're going to click again to reach the full speed. That's the full speed. That means that we have 5 volts here in that motor. Now again to turn off. That's it. We have 0 volts flowing through the motor. We're going to turn on the motor to see the difference between sleep and manual. So our blue light is going to decrease a little bit, the brightness, and our fan is going to turn off because we're in sleep mode. We click again. We go to sleep mode. The fan turn off and we have our LED lower. So if we put light on our photoresistor, the blue light is going to change in brightness. You see there is less light and we have back again. So we can turn on again, change the mode. We click again and we go to auto. So we are missing our interrupt section. So what we are going to do is, by hard coding, because we cannot reach a temperature higher than 35 right now because the temperature is perfectly fine. So we are going to change the variable in the code to make it the variable that if the temperature is greater than 20, the alarm mode is going to activate. So when that happens, this red LED is going to turn on and the active buzzer is going to make a really noise sound. And this one we are going to have a alarm mode. And also we are not going to be able to change between manual or auto. We are not going to be able to change between modes till the alarm interrupt moment stops, decrease the temperature. So one more thing is this part. This part makes the LCD change its brightness. So we're going to say this thing like that. That's 0. And here we're going to have our 5 volts. So we have to find a point in between to see our panel perfectly fine. So we're going to change our constant or temp alarm value, this one, to make the temperature less than our temperature in the room. Why? Because we want to code the alarm interrupt section. We are going to change this thing. The temperature is 23. We're going to say that the temperature is 20. This one we have to change it. We're going to put 8 and 4. We're going to run the code, change everything, and the red LED is going to turn on and the active buzzer is going to sound too. So let's wait. Here is the serial monitor. So since the temperature is greater than those 20 degrees Celsius, we have the alarm interrupt section. If we want to change between modes, we cannot do it. We cannot do anything till the alarm interrupt is done. We can hardcode again to be back to the default settings. We upload and the interrupt is going to be done.